Okay, so welcome back, folks. Happy Monday. We've pretty much finished up the unit on similarity. So I've got just a couple of quick elements to show you that wrap it all together. And then we'll have our test for this unit this Thursday. Okay. So I'd like you to look at this image on the screen here. Let me make sure that I'm, yep. So if I have, for instance, a quadrilateral A, B, C, D here, and another quadrilateral here, can you tell if this is an enlargement or a dilation or a reduction? What about if I do this? What if I call this A prime, B prime, C prime, and D prime? Right? Remember how when we put a prime symbol on it, that means it's a copy of the original? So in other words, if I were to dilate centered on the origin from A to A prime, from B to B prime, from C to C prime, and from D to D prime, we can see now that this is an enlargement. It's a dilation producing two figures that are similar. And in the event that I had something, I don't know, let's go with 3, 2 as the coordinate of D, and I knew that D prime was, let's say, 9, 6. Can we establish the scale factor? We can. Scale factor in general is equal to an image over a pre-image where they're corresponding. So in this case, for example, since I'm going from D, the pre-image, to D prime, which is the image, all I need to do is take an image component and divide it by the corresponding pre-image component. In this case, 9/3, which simplifies to 3. In other words, there's a scale factor of 3. Since this scale factor is greater than 1, that means we're multiplying it times a bigger number than 1. In other words, it's an enlargement. If in fact I were to readjust these so that it went from this point back to this point, now my scale factor would be like 2 divided by 6 or 1/3. I'd be seeing a reduction in size rather than an enlargement. Is this all familiar stuff? 5, I remember this explicitly. 3, it rings a bell. Still a little fuzzy. 1, I don't know what you're talking about. Okay, good. So the piece for today that I want to bring up is what if, for example, I told you that the area of this shape was 243 square units. Would you be able to figure out what the area of this shape is?
Do we know the scale factor?
We do. We just figured out the scale factor is 3. 81? How many of you guys think that's a reasonable call? I think what you did is you took the area of this one and divided it by 3 because that's the scale factor to get the area of this one. Does that sound logical? Okay, but let me take it a different way. Let's say that this is our width and this is our length. We could find the area of this quadrilateral. Let's assume it's a rectangle by doing what? Length times width. And if we're saying that these two shapes are similar shapes, then I know that if this whole shape experiences a scale factor of 3, then this side being W tells me how long is this side? W times 3 or 3W, right? And if this is a length of L and I'm experiencing a scale factor of 3, how long is this? 3L. Which means when I find the area, it's going to be base times height. What is 3W times 3L? 9LW. So instead of what we initially thought, that I could take the area of this one and divide it by 3 to find the area of this one, what we're seeing is that it's 9 times as much, not 3 times as much. Why is that? Because it's the area, but what is it about the area that makes it not just be 3 times as much, but actually 9 times as much? Let's put some units. What might be a reasonable length unit to use? Meters, inches, centimeters, right? And when I find area, if this is in meters and this is in meters, what's my area units? Meters squared. Because when I find an area, isn't it 2 lengths multiplied together? So if each of those lengths has a scale factor of 3, when I multiply them together, wouldn't that area measurement be a scale factor of 3 squared? So it turns out this is where we're going with this. In the event that we have similar figures where the scale factor is A over B, any ratio, and we're looking at the area scale factor, don't really call it scale factor because that's a length one. If the scale factor of any lengths were A over B, what would be the scale factor for the area? Very good. Because each of the dimensions multiplies times another dimension. And if we were to take it to a point of having a volume ratio, what would that be? Because when you figure out volume, you do length times width times height, don't you? The A cubed over B cubed. The ratio, if this one is L, W, and H, and the other one has a scale factor of A over B, then this one will be A over BL times A over BW times A over BH. And so the volume, would that be A over B, A over B over B, A over B cubed? Now, what this is going to look like is, for example, if I were to tell you that I've got 2 quadrilateral prisms, and I know we don't know those terms yet, but let's say that these 2 shapes are similar. And if I tell you that corresponding sides are in the ratio of 3 to 2, then my length ratio or scale factor is, let's say, 2/3. What would my surface area ratio be? If I were to like paint the sides of these things and compare how much paint it would take. Good, that's an area ratio, so it'd be 2 squared over 3 squared, or 4 over 9. What if I said that I wanted to see how much water would be in it? Yeah.
2 cubed over 3 cubed.
Good. 2 cubed over 3 cubed, which would be 8 over 27. What if I asked to know the ratio of all the corner edges compared? Is that a length, area, or volume measurement when we talk about adding up all these little lengths? Length. So we just say this is what? Be the original, 2 over 3. Anything in these 2 similar figures that's dealing with length is going to be 2/3. Anything dealing with area is going to be 4/9. And anything dealing with volume would be 8/27. All right, so that's the last piece of the unit effectively. You'll notice what you've got in front of you is a little piece of paper that tells you the skills that I endeavored to teach you this unit. If you go through these and give yourself a score of 1 through 5 as an initial self-assessment, this will give you a nice little target. How prepared are you right now for the test on Thursday? If you don't know what these things mean, it's going to be a low score on there, right? If you need a little nudge as to what they mean, like for example, I called it the side splitting theorem, and I think we called it triangle proportionality. Do the self-assessment. do the review packet. You'll have today, little time on homework tonight, all day Tuesday in class, maybe one more little assignment, and then of course Tuesday night homework to prepare for a Thursday test using that review packet. And I would say right before the test, you want to check your skill set again, see if you're prepared for the test. Okay, I think you've got the tools you need. You have the rest of this period to prepare. If you have any questions, come on up. Here it is yours.